we are picking up in 8.4 where we left off. And kind of, I wish we would have gotten through number 2 had I realized or remembered what number 2 was. But number 2 starts off saying this leads to a general approach we'll use for finding the area between two curves. And it talks about find the area between the two curves algebraically and show your work. Okay, so if I backtrack a page for a moment, okay, well, first of all, notice the integral from 0 to 5 of f of x minus g of x. We talked about this yesterday before I turned the page, right? And the idea here that, you know, if we're trying to find the area between these two graphs, so like that top part of that parabola there that I had outlined in orange yesterday, we basically talked about we were going to do the blue minus the green, right? And we did the blue minus the green. Basically, that's going to be the area under the parabola minus the area under the line. Okay, so the idea is you'll often see like a line drawn here to kind of represent that is the distance, you know, not distance, but that's a representation of a piece of that area that we're finding. Okay, now if you go back and look, the top one is f, the bottom one is g. So thus the integral of f of x minus g of x. Now, if we go over here, first of all, realize officially this integral can be rewritten, right, as the integral of 0 to 5 of f of x dx minus the integral of 0 to 5 of g of x dx. That's just our basic integration rules that you can split that integral there. What do we already know from our previous page? The integral from 0 to 5 of f of x is 145 over 6 minus the integral from 0 to 5 of g of x dx, 55 over 4. And those were the two values that we found yesterday. From here, we can subtract, yes. Calculator, maybe. If you don't use a calculator, what do you have to do? Common denominator. What does 6 and 4 both go into?
2.
I'm looking for the 12 answer. So 6 times 2 is 12. 145 times 2 is going to be 290. 4 times 3 is 12. So 55 times 3, 165. So 290 over 12 minus 165 over 12. 125 over 12. Okay. And it depends on the scenario. Do you have a calculator allowed? Do you not? You know, if you don't have a calculator allowed, then that's your best answer. If you do go calculator, I don't know if anyone did on the calculator, you end up with 10 point something. Yeah. I have written down 10.4167 or 10.417, I guess. Didn't you get, weren't you the class that got on me about the devil the other day? And there's Tate now saying all the 6s. Okay. So, okay, keep that in mind, guys. That is upper minus lower, yes? Okay, so when you've got two graphs we're working of, one's above the other one, it's upper minus lower on that interval, and we're going to work in terms of x's. Okay? Let's look at number 3. Find the area between curves expressed as functions of y. So you'll notice here they talk about horizontal rectangles and the y-axis approach. Do we have an upper minus lower curve that we can talk about?
Yeah. Right minus left.
Okay. We definitely have a right minus left. In some spots, like, you know, from -1 to 2, the line is above the parabola, yes? But from 2 to 3, it's just a parabola. So that complicates the issue of doing upper minus lower. So we're going to instead do right minus left. Now, when we start talking about right minus left, you'll notice it talks about horizontal and it talks about the y-axis approach. On the previous page, I talked about a representative piece being that vertical slice, right? Well, now the representative piece is going to be a horizontal piece. Gosh. Okay. Now, okay, find the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. Now, with that in mind, okay, so this is what I kind of already talked about, this note here. With respect to x, if we are doing this in terms of x, this is what I already talked about, that from -1 to 2, you'd be okay, but then 2 to 3 would be the issue. With respect to y, so if we're working in terms of y, we can just use one integral. Okay? So now, x equals 3 minus y squared. Which one is that? Is that the parabola or the line? That's the parabola, right? So this is the x equals 3 minus y squared. X equals y plus 1 is the line, right? Okay. As we look at this, we're finding the area between two curves, right? So if you will, we're finding the area in between those two curves. Okay. I don't know how well you can see that yellow, but you don't have to be able to see it great, right? Okay, guys. If we talk right minus left, what is my right? Which is the right curve? 3 minus y squared, right? So when we set up this integral, okay, we're going to be doing area, and it's going to be the integral. Right curve minus the left curve. So the curve that's on the right side of that yellow area is the 3 minus y squared. Because we're doing right minus left, we're keeping this in terms of y. Okay? And then minus, what's my left curve? The y plus 1. So we're going to do 3 minus y squared minus the quantity y plus 1. Notice everything was x equals, it's all in terms of y. So there's our integral dy. Okay. Now, we need some boundaries. Okay. We need our limits here. Notice we're working in terms of what variable? Y's. Which means my values, my limits, are going to be y values. Okay. So the bordering points, can you agree that are these 2 points? And this ordered pair down here at the bottom is what? -1, -2. This ordered pair up here is 2, 1. Okay. I need the y values. What are my y values? So we're going to evaluate this integral on the y value from -2 to the y value of 1. Okay. Are we okay with that? Okay. Now, from here, we just need to do some math. One thing you could do is you can clean up inside that integral. What do I mean clean up inside the integral? Can we combine some like terms before we integrate? It'll save us a little integration. We'll be integrating not all 4 terms, plus it'll save us a little bit of when we plug the values in. So when we clean this up, what do we end up with?
2 minus 2y squared. 2 plus 2. Can't be on. Plus, no, minus. It's minus. It would be minus 2y squared. Minus y squared minus y.
Because our y squared and y is like terms.
Yeah.
You know that. Okay. Now, if you don't like them in that order, you can rearrange the order. It's not in a very, normal order, but it doesn't really matter for what we're doing. Okay, ready to integrate?
Okay.
Integral of 2.
2y.
Okay. With the constant, you just add the y. Minus integral of y squared.
1/3 y cubed.
Add 1 to the power, divide by the new power. So 1/3 y cubed. Minus the integral of y. Add 1 to the power, divide by a new power. Evaluated from -2 to 1. Okay, ready to plug in? I like plugging in 1, that'll be easy. 2 minus 1/3 minus 1/2, right? And I had that in parentheses, and minus. Now I'm going to put in -2. 2 times -2 is -4. -1/3 times -2 cubed. Well, -2 cubed is -8 times -1/3 is going to be +8/3. And I'm not worrying about this subtraction right now. We'll come back and get that other subtraction here in a moment. -1/2 times -2 squared. -2 squared is 4. -1/2 times 4 minus 2. Okay, that's not horrible, is it? Or, if we don't have calculator options, clean it up by hand.
2 plus 2.
Now, looks like in my notes I just got a common denominator on everything. However, I'll be honest, I would kind of clean up the like pieces first.
So 2 minus -4.
2 minus -4, so that's going to be 2 plus 4, which is 6, and minus -2. So plus 2 is another, we're at 8. I can put thirds together. Minus 1/3 minus 8/3 minus 9/3. But 9/3 is 3. Ooh, I like this. And then what? We just have a -1/2? I don't know. You have to do you, right? If you're having to do this without a calculator, you have to do what works for you. So 8 minus 3 is 5. 5 minus 1/2 is 4.5. 4.5 improperly is 9/2. Or I guess you could have just said 4.5. I honestly don't know. We don't really use mixed numbers once we get into Algebra 1. I really don't know how AP Calc feels about mixed numbers. Like if you put 4.5 on there, I really don't know. So, random, I know. Okay, I just saw my notes. You guys caught this. WRT. Did you guys catch what I said that stands for? That is with respect to. So, just for the record. I think the first time I looked at it, I'm like, well, what? Am I supposed to know this abbreviation? Until I thought about it, and I was like, oh, okay. Okay, guys. You're seeing the basics, right? Upper minus lower, we work in terms of x's. Right minus left, we work in terms of y's. Okay. Let's look at example 4. Finding the area between the curves that intersect at more than 2 points. Okay? So we're going to look at what exactly that means. So find the area of the region between the graphs of f of x and g of x. Part A asks us to find the intersection of the two curves. Okay, play the game if you don't have the calculator. Okay, in other words, the easy part is, oh, we put this in on the calculator and we use the graph to find the intersection, right? But okay, play the game. What if I don't have the calculator option here? How do I find the intersection points of these two curves? What do we want to know?
They cross the x and
Okay, we're looking for where F and G cross. What's going to be true when they cross? They're the same. They are equal. So in order to find the intersection, we're going to set f of x equal to g of x and do some good old-fashioned algebra. 14x plus x squared minus 2x cubed equals x squared minus 4x. Okay, what are you thinking here? Everyone's working. You guys must be working without me. Are you making your equation equal to 0?
Yeah.
X squareds cancel, right? I set mine up so my 2x cubed was positive. I have 2x cubed minus 18x. Or you have negative 2x cubed plus 18x. Did you factor? There's a GCF of 2x. Then I've got 2x times x squared minus 9. Did you set them equal to 0 right here? You can either set them equal to 0 right here, or did you factor the x squared minus 9?
Well, you could just do that.
I mean, it's either or. Neither's more right or wrong than the other. Neither are wrong, but
X equals plus or minus 30, and x equals 0.
yep. So we found x values to be 0, negative 3, and 3. Now, in all honesty, I don't know. Technically, does it even look like we needed to find those? You can kind of see them on the graph, but here's the deal, guys. It asks for the intersection of the two curves. I need a little more information. What am I looking for?
Value, a point.
Uh-huh. I'm looking for points.
Plug those into the equation. Does it matter
Okay.
which one you plug them into?
Nope. So you're taking 0, negative 3, and 3, plugging them into whichever equation makes you happier.
First one, 0, 0.
I agree with the 0, 0. That's an easy one.
3. I got this back.
Now, I personally plugged mine into G because that was the easier one to do mentally. Again, it doesn't matter. It's the same F and G. So I have negative 321, 0, 0, and 3, negative 3. Okay. Now, those points are going to be important. You have to know them for fact. You can't just be, the graph kind of looks like it crosses there. Unless you're looking at your calculator, you don't know for sure if this is drawn accurately. Okay? Now, B asks us to write the integrals and calculate the area. Okay? Okay, so the idea is to find the area of the region between the graphs.
So is that just whenever they make a shape, I guess you could say?
Kind of. Whenever they make a shape, I'll take that definition. I don't necessarily have a better way. So notice, what does that mean? We're finding not one, but two. We've got, okay, I thought I'd change colors because I was trying to go for something lighter. Here. Ooh. We've got this first shape, right? I don't have a name for the shape. But we have that first shape. And we have a second shape over here, yes? Second shape is kind of like a parabola. Yeah, well, I guess they both are parabola pieces, but. Okay, so the idea here is I'm going to call this area 1 and area 2. Okay, that's the gist of what we're doing. We're trying to find the area of the first shape plus the area of the second shape, and that's going to give me my total. Okay. Now, let's talk about area of the first shape. Okay. How are we going to do area 1? Top minus bottom.
Let's see. Which
Just keep in mind.
G of x minus f of x.
Okay. Top minus bottom there.
Yeah, how do you know where you draw the lines?
Okay, so, and I haven't explained that really, have I? Kind of. The line is just the idea of, okay, what we're trying to integrate is the difference from the top to the bottom, right? These equations are in terms of their y equal equations, right? So you're really integrating essentially from that y to that y, the top y to the bottom y. But these y values have equations for them. Okay? The idea is, we've got an upper curve minus a lower curve. So that it's technically, I draw it as a line, it's more of technically a rectangle. It's like a little section. Because keep in mind, okay, here's where I need to connect. Integrals. What were we doing with integrals? We first start off adding rectangles, yes?
Yeah.
So that's like one representation of the rectangle. When we're doing upper minus lower, it's a vertical rectangle. If I backtrack over here, we did right minus left, that rectangle is a horizontal piece. Because that rectangle is from x value to x value here. Okay?
How do you decide where to put it? Does it matter?
Oh, like where to put it? Like I put it right there as opposed. No, it doesn't matter.
Okay.
Okay, I didn't understand the question.
That's what.
No, in other words,
Those are just visual.
So we don't.
it's just a visual representation.
of
I randomly put it here. Over here, I'm just going to randomly put it where there's a spot.
So we don't use the x-axis as.
Upper or lower?
Yeah.
Nope.
Oh, yeah,
Nope, we're just doing upper curve and lower curve. The x-axis happens to cut through the middle, irrelevant.
So basically, we just divide them up to make it easier to find them.
Well, okay, so on this one, I forget, I think you guys told me, when we said upper minus lower, it's going to be what? Which one's the upper one right here? The,
Oh, the x squared minus 4x.
okay, so g of x is upper, sorry, minus what's the lower curve? F of x. What's going to happen over here in my blue one?
f(x) is that.
It's going to be f of x minus g of x. Does that make sense? And so that's why I had to divide it into two pieces, because my upper and lower, when they crossed through at 0, 0, they flipped. Did I make some progress there? Sorry, guys.
Yeah.
I was being confusing. I realize that. Okay, so in order to do area 1, okay, g of x minus f of x. So g of x is x squared minus 4x. That's your upper. Minus f of x, which is the 14x plus x squared minus 2x cubed dx. Okay? Now, I almost forgot before we go on. I need boundaries.
-3 to 0.
Okay? So keep in mind that this ordered pair was -3, 21. This ordered pair is 0, 0. And when we get there, this ordered pair is going to be 3, -3. Since we're doing upper minus lower, my equations are in terms of x's, and we're working in terms of x's. So what are the x values I need? The -3 and the 0. Good. Okay. And as we said, I'll just write it in here. That was g of x minus f of x. Do some math. We've kind of already done some of this math, haven't we? What's this clean up to be? Except that I can't move it to the other side to make a positive 2x cubed, can I? So this is going to be a positive 18x minus 2x cubed, if you will. Because I don't have another side of the equation. So we'd already done that up above. Now we're ready to integrate. Wait a minute.
I know that's right.
Wait a minute.
I was just shooting a guess and you went with it.
Wait a minute. Why? Okay. My apologies. This one, we still have another one to do over here, so. This does clean up to be -18x
Right.
and a plus 2x cubed. My apologies. Are you with me? Okay. Let's integrate. -18x. Add 1 to the power, divide by the new power.
Oh, it's already mixed. Sorry. Made 9x right.
Add 1 to the power becomes x squared. You divide by that 2, it's -9x squared. Plus -2x cubed. Add 1 to the power, divide by a new power. Yeah, 2/4 or 1/2. Whoops. 1/2 x to the 4th. And this is going to be evaluated from -3 to 0. Now, which means you're plugging in what first? 0. So you plug in 0. It's 0 plus 0. Okay, that's nice. Minus. Now we're plugging in -3. -9 times -3 squared.
-81.
Yeah, that's better than my math. Don't ask. I know. Okay, -3 squared is 9 times -9, -81. -3 to the 4th. Well, what's 3 squared?
27 times 3. 6. 21. 80.
Wait a minute.
It is 81. Now, here's my thing, guys. 3 times 3 is 9. The other 3 times 3 is 9. 9 times 9 is 81. Because my brain, like Tate was struggling with 3 times 27. I can't do that very quickly. 9 times 9, I got. So, okay, so -3 to the 4th is 81. Ugh, half of 81.
Oh,
40 and a half.
Yeah. 40.5 or 81 halves. Whichever you want to do there. What is -81 plus 81 halves? Think about it this way. What's -81 plus 40 and a half?
20. No.
121.
40 and a half.
40 and a half? Because if this is half of 81, right?
No, a negative 40.
So, okay, so in my parentheses, negative 81 plus 40 and a half is going to be negative 40.5. The opposite of it out front makes it a positive 40.5. So you could say 81 halves or 40.5. Okay. Now, folks, that was area 1.
We gotta do the other one too.
We got to do area 2. How are we going to do area 2?
Flip it.
F of x minus g of x.
Okay, f of x minus g of x, it is being flipped. So now, 14x plus x squared minus 2x cubed minus x squared minus 4x dx. And as stated, that was doing f of x minus g of x. We'd already talked about that. What are my boundaries?
0 to 3.
Okay, 0 to 3. Now, we can cheat off of ourselves some, yes?
Yeah.
So it's 0 to 3. When we clean this up, well, not that's,
Backwards.
now we're at
18x minus 2x.
positive 18x minus 2x cubed, which is what your teacher tried to say last time, but we're just not even going to talk about that. We already integrated this just with the other signs, right? What am I doing? Integral of 18x. Oh my goodness. Positive 9x squared minus 1/2 x to the 4th. Evaluating from 0 to 3. Plug in 3.
81 minus
81 minus 81 halves. Plug in 0. That's 0. So 81 minus 81 halves. 81 halves or 40.5. Now, that is area 2.
So, area is 81.
Area is what?
Total area is 81.
81? Because officially to finish this off, we're doing the area of the first plus the area of the second, which was 81 halves plus 81 halves, or 40.5 plus 40.5, which is 81. Okay? Now, they're not always going to all be that difficult where it's 2 sections, but they will be at times. Okay? The more difficult they get, the more likely you're going to be able to use the calculator. So that's always a good thing, right? Okay. Ready for example 5?
One of the reasons.
Options.
Okay. Find the area of one of the regions bounded by the sine and cosine curves. Now, we have a sketch note where f of x is greater than or equal to g of x. F of x and g of x, we have to define what's what. We have to decide our boundaries, our a and b, and we have to integrate. Now, it says find the area of one of the regions because aren't they all the same?
Yeah.
I mean, reflections of each other, but we just need to find one of them. Which one do you want to find?
Left, right, all. I'm just kidding. None of them.
I'm going here for the one I'm sketching, or I'm shading in blue. Okay? Now, with that information, okay, they want us to state which graph is f of x and which graph is g of x, based on the fact that f of x is the greater graph, g of x is the smaller graph. So basically higher and lower. Now, okay, My pre-calc kids just quizzed on this today. Which graph is the sine curve? Which graph is the cosine curve?
Sine is hill and valley.
Wait, doesn't cosine start at 1?
Mhm.
Yeah.
Yep. So sine is hill and valley. It starts at 0, 0, goes hill, valley. Cosine starts at 1. It's just the valley in between the two hills. Okay? So that means f of x. So on my particular blue shaded section, which curve is on top?
F of
Which is
Sine.
sine x. So sine x is going to be defined as f of x. G of x is going to be defined to be cosine x. Keeping in mind, if we went to the next section,
It'd be different.
it'd be flipped, right? If we went and did this second section, it'd be flipped. But in reality, find one section and multiply it by 2 if you needed both, right? Okay, so now, with this in mind, can we do upper minus lower? Yeah, we have one graph that is always on top, one graph that's always on bottom. So we're going to be able to do upper minus lower. And keeping in mind, so that means the representative rectangle is a vertical rectangle that goes from top to bottom there. Okay, because we can work in X. Okay, we need bounds.
Pi over 4 to 3 pi over 4.
Okay. Pi over 4 should make sense.
Yeah, if it's a quarter, right? Pi over 4.
Okay, it is a fourth. Also, think about our reference chart.
Oh, chart.
What do we know about sine and cosine of pi over 4?
They're the same.
They're the same, yes? So that makes sense that one of ours is going to be at pi over 4. And what's going to be the y value at pi over 4? The sine or cosine of pi over 4 is square root of 2 over 2. Now, basically, what's the one then that's between pi and 3 pi over 2? That is your 3 pi over 4, yes? Basically, it's your pi over 4 graph in quadrant 2. And that's going to be 3 pi over 4 comma what? Negative square root of 2 over 2? Oh, whoa, 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 whoa.
We messed up.
Hold. Yeah.
What do we do?
Because we're not going to pi.
That's not 3 pi over 4.
No, she's past pi. That is 2 pi over 2.
Oh. 5.
Well, okay, here's where I all of a sudden struggled.
5 pi.
3 pi over 4 is in quadrant 2.
Right.
Do sine and cosine have the same sign in quadrant 2? All students, sine is positive, cosine is negative, and that's where I started. I was like, something's not right because I need them to have the same y value here. So, and then, as pointed out by someone, it's past pi. So what is it that's between pi and 3 pi over 2? Now we need to talk 5 pi over 4. I feel like I am off my game today.
I
You too.
That's what we.
Man, I don't know. I'm struggling. I don't know why, but.
Wednesday.
Okay. Now, are we good with 5 pi over 4? Speak up if you're questioning me, because I'm obviously very possible to be wrong today, as I have shown multiple times. Okay. Now, I can agree that these are both negative, yes? Because in quadrant 3, all students take the tangent quadrant, so sine and cosine are both going to be negative. Okay. Man. Okay, guys, it says integrate. We're trying to find the area of we're in the first section, the blue one. Here you go, guys. That's what you get from me. What are we going to do?
So it'll be what would be the f of x minus integral of sine x minus cosine x.
Yep, good.
Integrated from 5 over 4 to 5.
Yes, good. Are we all together on that?
Yeah. This looks like one we should just plug into the calculator. I agree.
On the flip side, it's good trig practice. Okay, so the integral of sine.
Cosine.
Negative
Negative cosine. Negative minus negative sine x.
Plus sine.
Wait. Yeah, it would be plus sine. Because it's just subtracting.
Be minus sine.
Or minus sine.
The integral of cosine is sine.
The integral of cosine is.
It's just sine.
The derivative of sine is cosine, is what you're trying to say, I think.
Yes.
The derivative of sine is cosine.
Yeah.
Right.
So the integral of cosine
Is sine.
is just sine. The plus minus part stays the same.
Yeah.
It's been a moment. I'm having to, okay, so, because I was still struggling to make sure I had the sign correct on the first one. Okay, evaluated from pi over 4 to 5 pi over 4. Okay, I'm going to write it out and then we can fill it in. Negative cosine of 5 pi over 4 minus sine of 5 pi over 4 minus, parentheses, negative cosine of pi over 4 minus sine of pi over 4. No, and this is where I'm going to stand by. This is really good trig review. And this is really kind of basic trig review to an extent. Okay, now, okay guys, we've kind of already talked about, but where is 5 pi over 4? Quadrant 3, yes?
So it's
And 5 pi over 4 is going to have the same values as pi over 4. We just have to think all students take calculus in terms of our signs. Does that make sense?
so it's negative pi over 4. No, it would be positive pi over 4.
Well,
Negative square root of 2 over 2. Yeah.
okay, so cosine of 5 pi over 4, ignoring any positive negative signs right now, cosine of 5 pi over 4 is going to have the same answer as cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. Now, in quadrant 3, what do we know about cosine? It's negative. So now we have the negative right here of a negative square root of 2 over 2, so it's going to be a positive. Now, over here, sine of 5 pi over 4 is also square root of 2 over 2. It's the minus sign, and what do we know about sine down in quadrant 3? So it's going to become a plus. Okay, we got that one. Minus, I'm just going to leave the minus signs in between right now. Negative cosine of pi over 4. What do we know about everything in quadrant 1?
All positive.
Everybody's positive, yes? So negative cosine of pi over 4 then is actually negative square root of 2 over 2?
Yes.
Because cosine pi over 4 is square root of 2 over 2. Since it says negative, we're going to say negative. Minus another square root of 2 over 2. Now, okay, think about this, guys.
I'm just gonna cancel.
Square root of 2 over 2. Does it help if I say that's a 1 square root of 2 over 2? So right here, in this first parentheses, this is like 1/2 square root of 2 plus 1/2 square root of 2.
They just can't. And it's square root of 2, it's just square root.
Right, like so 1/2 plus 1/2 is 1. So in that first parenthesis we have square root of 2 minus, now over here, negative 1/2 minus 1/2 is going to be a negative 1, so negative square root of 2, but we also have the minus sign in between, so square root of 2 plus square root of 2 is,
Two.
Wow.
It can't just be two.
no, it's like saying what's x plus x,
2x.
2x.
Oh.
So what's square root of 2 plus square root of 2?
Oh.
Okay, we worked our brains hard on that one, didn't we?
did. Oh.
Okay, guys,
Let me make a guess.
here's my thought.
3 for.
Okay.
Make it a 3 for.
Now,
Make it a-
I shouldn't, but the only reason I'm doing it is it bumps a couple of things. It bumps your quiz off Monday to Tuesday. Okay. I was already struggling and not going to be able to get the test in before spring break like the preference would be.
Yes.
So we're just going to have to come back after spring break and spend several days reviewing, which not ideal, but it's not like I'm going to give the tests right when we come back after spring break. We'll take the time to review. Okay. So, that bumps it now to what? The Monday after spring break if we're thinking school days, but we're not here. So, No. Okay, so tomorrow, here's the mindset I need you to come in with.
Finish real fast. But
Finish 6 and 7, which 6 is going to take some time, right?
Yeah.
7's a quick one, but
Bus.
finish 6 and then plan to work some tomorrow.
Oh, we're getting done.
Holy
Okay.
cow.
Plan to work some, and then you have some good homework to do, don't
3
you?
pages, but they're all.
3 pages. You're drawing pictures on all of them. That's really a big thing because you have to kind of sketch the graph to know what you're doing.
Homework
So.
questions tomorrow.
Okay, we could talk about some homework tomorrow. Okay, no homework due tomorrow.
That's good because we're all going to the game.
That's good. Okay,
We're going to get out early.
Caitlin, hopefully you heard. We're going to do a third day. Quiz will be Tuesday.
She's not here.